Good morning, my dear friends. Another small topic in this chapter is, something called kern points and kern distances. So, what exactly this is? Let us try to see now. Kern points and kern distances. In the last class, when I was discussing with you with respect to this pressure line or C line, I said you that in the beginning your F force and C force will coincide. Am I right? No, they are coinciding. As the load is increased, your C force starts shifting upwards. Am I right now? It starts shifting upwards. Suppose now, I will ask you a simple question now. Is there any chance that if I put more load, is there any chance that this C force may act beyond this beam, beyond the cross section of this beam? Does it act here? C force? No, it cannot act. Am I right now? Because, see one now, when it acts at certain point, say take for example now, here it is now acting now. C force is now acting here now. Okay. At that, when C force is now acting, because of this bending moment, the beam is bending like this now. The beam is bending. Am I right, sir? Now, the beam bends like this. Okay. Whenever it bends like this, okay, you know that tension will come at the bottom, compression will come at the top. You said now. But now, when this C force acts here, okay, this tension, this tensile stress in the concrete may exceed the allowable compressive stress. Okay, sir. Now, so now I should not allow this C force to act beyond this point. If it acts beyond this point, say beyond this point, okay, so I will mark here a line. Okay. If it acts beyond this point, okay, the allowable tensile stress in concrete may exceed, so it may crack. Okay, so now I should not allow this C force to act beyond this point. It should not act beyond this point. Okay, similarly, Baba, this happens in the working condition, in the sense when the live load is now acting. In the working condition, I should not allow this C force to act beyond this. So now this distance, okay, this distance from CGC, this is your CGC line, okay, this distance I will call it as KT. In a sense, this distance I will call it as upper kern distance, and this line we call it as upper kern line. I will call it as. Okay, only thing is now I should not allow the C force to act beyond this limit. Okay, beyond this limit. So this distance I will call it as KT. Okay, upper kern distance from CGC. Okay, similarly, now I should not, in sense now, whenever there is no load at all now, assume that there is no load in the initial condition, okay, I should not allow this C force to act below some point now. It should not act below this. If it acts below this, Baba, whenever in the initial condition the beam tries to hog, as I said, the beam tries to hog. Am I right now? The beam tries to hog like this. Tension is at the top, compression is at the bottom now. Okay, so if you allow this C force to act below this, Baba, top fiber stress may exceed the allowable tensile stress and it may crack. Understood or not now? So now I should not allow the C force to act below this line. So now here is a line. Okay, I am going to draw this line, and this distance I will call it as KB. In the sense, this distance is now bottom kern distance, KB, bottom kern distance, or this line I will call it as bottom kern line, or this is called bottom kern point, this is called upper kern point. Okay, so now that is how, Baba, now a concept called kern points and kern distances will come into picture. Okay, see now, this is our CGC I have drawn here now. Okay, a line, it is called top current line. Okay, under any circumstances, your C force should not be allowed to act beyond this. If it acts beyond this, bottom fiber stress will exceed the allowable tensile stress. Similarly, okay, and in sense it should not exceed this A point beyond this. Similarly, here is a B point. Observe now, wherein in the initial condition, your C force should not be allowed to act below this. Okay, otherwise the top fiber stress will exceed the allowable tensile stress. Okay, so that's why we call this as KT, this as KB. Okay, top current point or top current distance KT, bottom current distance KB, or this point is called upper current point, this is called lower current point. Okay, this is called top current line, this is called bottom current line. Was that now? Now the problem is now how to find out the values of this KT and KB. KT and KB. How to find out the values of this KT and KB? Now, Baba, with simple this thing, we shall try to see how exactly KT and KB can be now found out. Papa, in the initial condition, observe now. Otherwise, observe now. I need not explain all these things now. KT can be found by one equation, something called 1 minute. Excuse me. KB can be found by one equation, r square by yt. Observe now, where r is, it is the radius of gyration. KB is given by r square by yt, radius of gyration divided by yt. Yt, you know that it is the upper fiber distance. Okay, KB is given by r square by yt. Similarly, KT is given by something called r square by yb. Okay, this is the equation, r square by yb. Okay, other actual equation is KT is equal to r square by yb 1 plus ACT by eta f. So now, when CT is, it is the allowable tensile stress. When we assume that allowable tensile stress in concrete is 0, this becomes 0. Am I right now? So it will become only r square by yb. Okay. Similarly, your KB value, its equation is now r square by yt into 1 plus ACT by f. If suppose where CT is now, it is the permissible tensile stress in concrete. If I assume that permissible tensile stress in concrete CT value is 0, then this becomes 0. Entire things becomes 0. At that time, KB becomes only r square by yt. It becomes only r square by yt. So now you can just remember KB value can be calculated as r square by yt, and KT value can be calculated as now r square by yb. Okay, these are the two equations which you will have to remember. Okay, so now that is how the concept of current points and current distances happens. Okay, only thing is now you should not allow your C force to act beyond this point or beyond this point, either in the initial condition or in the final condition. Okay, thank you very much, my dear friends. Thank you.